Let's have a look at a question that contains mass spectroscopy and infrared spectra as well. So once again, have a look at the question. There might be some information that will help you out. So I see the empirical formula. Now, empirical, I have to be very careful from that because it could, be double A, so it could be C10H20O2. But I can see because of the small number here in my mass spec, that this probably is going to be C5. Okay, so let's have a look what we do here. We find the highest peak. Now QCAA is not going to make it too difficult for you. So they've already indicated the three major peaks. So we want that 86. It's our mass for the compound. So what I would first do is I'd quickly do a calculation to see if that matches. So we're going to go 60, 10, and 16, which is 86. So I know that that formula is right. Now I know there's one, I technically don't need to go through my rule of 13, but let's do it anyway. So I know I have one oxygen. So I'm going to take that away from this, and I end up 70. Now we divide by 13. 13 is a carbon plus a hydrogen. So that will go into it 5 times, and I will have a remainder of 5. So I know at the moment I have this. Okay, 5 lots of this. Now I have a remainder 5, so that means I have another 5 hydrogens. So my chemical formula should be this, and that's what I already have. Now we don't know if it is an alcohol or an aldehyde or a ketone. So we're going to have to play around a little bit with this. Now we go down to the infrared spectrum. So this gives me a lot more information here because I can see that I don't have that OH group. So it's not an alcohol. Okay. What I do see is this here from 1700 to 750, which is my carbonyl group. Now I just want to quickly check that there's nothing here. There's no double bond here. Okay, so I know now that this is going to be either an aldehyde or a ketone. Okay, so let's start by drawing what the structures could be. So I'm going to start with my aldehyde. And I'm going to do my 2 ketones that are possibly could. So I can have one here. I could have one here. And I'll put my hydrogens in. You notice they all have 10 hydrogens. So let's have a look now. So we want to have a look at 43 and 73. They're our major numbers. 43 and 71. So, okay. How do I get my 71? Can I get it from that? Yes, I can. That was missing. Can I get it from that? Yes, I can. Can I get it from these? Well, technically I can as well. Now, this is the problem with this question that chemistry teachers we were quite annoyed with. So let's have a look at this bit here. Can we break this down a little bit further? We've got 3 carbons, so that's 36. We've got an oxygen, and we've got 1, 2, 3, 4, 5 hydrogens. So that gives me 52, 57. Now if I go up to here, Use a tiny little bit at 57, so maybe that is that one. So let's see if we can find something that has 43. So let's look at this here. We've got 24 plus 16 plus 3. That gives me 43. I find a 43 on this one. 36, 40, 52. So I can't find 43. Okay, so it's probably not going to be this one. Now, can I find a 43 on here? Yes, I can, because that is 6, 143, 142, 43. That's a 43 as well. And that would be a 43 too. So this is where it gets a little bit tricky. Now, because we have two 43s here, it's probably more likely going to be this one here. Simply because we can see that that 43 is a very, very large peak. Now, it only occurs one time with the aldehyde, with this group here, whereas we've got it twice here. So just by that alone, we might call this the ketone. And it is going to be pentanone. It's going to be 2 pentanone. 4 pentanone. Okay. The problem with this question was that many of us didn't agree that, it could be QCAA should give points for either of these. The the reasoning that it is the ketone and not the aldehyde is actually second and third year chemistry stuff at university. It's called the McLafferty reaction, and there's no way that that would be in the year 12 syllabus. So QCAA have kind of stuffed up a little bit on this question, where it is actually both. They have to accept both answers here. So what would I say as my reasoning? The 1 mark I would say would be can't be an alcohol. 1 mark is that you have that there. So it's either a ketone or the aldehyde, and then breaking it down here into your sections, and showing that it can't be the 3-pentanone because there's no 43, and then figuring out if this one has multiple 43s, so it's most likely going to be that one. Okay, so with mass spec, if it's just mass spec by itself, it should be a lot clearer, and they would probably have to give you whether it contains oxygen or not. You couldn't work it out otherwise. If there is an infrared spectrum, then you may have to work it out yourself, the empirical formula, the chemical formula, using the rule of 13, and identifying if it contains any oxygen in the first place.